Good morning. I'd like to walk you through this worksheet that's for homework over Thanksgiving week. Maybe you can use it as an excuse if you want to get away from family time, and you can blame it on your physics teacher that you have homework. I also just want to keep your brain in shape and be ready to go when we get back. On this worksheet, we're working on word problems that will include things that go at a constant speed and things that are speeding up or slowing down. So the two possible equations that we could use include this one on the left. If we have constant velocity or constant speed, I'm using those words interchangeably, and the one on the right, v equals at, we can use if we have things that are getting faster or getting slower. So when you read the word problem, get an idea if this thing is getting faster or getting slower, and then you'll know which of the two to choose. So you either choose the one on the left or the one on the right. The x equals vt stands for the distance something moves, or its change in position, is equal to its velocity times time. Or in our class, we've said a lot of times, the speed times time. So these two things are just in words what I wrote up here. And then on the other side of the dashed line, the velocity, v, is equal to acceleration times time. Or you could also think of it as the speed is equal to the acceleration times time. So these are just both the same thing, both trying to tell you in words what these symbols mean. These are really your two possible equations. You need to pick one when you're doing the word problems. Looking at the word problem now, make sure to use the guess method. G means circle anything that's given. U, underline anything that they want you to solve for that's unknown. E, write the equation. S, substitute. S, solve. So let's do the first one together. An airplane accelerates from rest down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine how fast it's going as it lifts off. So I see here a really important part that it's accelerating. So I already know which equation I'm going to use, the one that has acceleration. I see the word from rest. So I know that that's the starting speed or starting velocity of 0 meters per second. I see here that it's accelerating 3.2 meters per second, or 3.2 meters per second squared. This is the acceleration. And the amount of time that this happens is right here, 32.8 seconds. How fast is it going means we want to know its speed or its velocity as it lifts off. So I've already determined my equation is going to be v equals at because there's acceleration in this problem. And in fact, they give me the acceleration. What I don't know, the unknown, is speed. Here, this will give me the unknown of speed. So leave the v. 3.2 meters per second squared is the acceleration. T is for time, 32.8. And I'll leave you to do the multiplication to figure out the speed of the airplane as it takes off after it has accelerated down the runway. Let's take a look at one more. Number 2, a race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second in 2.7 seconds. Determine the acceleration of the car. We use the guess method. We see they've given us a speed and another speed. So this is the first velocity, or velocity 1, or you could call it velocity initial, and this one is the second velocity, velocity 2, or velocity final. We see here a time. We know that it accelerates, and we'd want to find out the acceleration of the car. So A, acceleration is there. So, this looks a little different than what I'm used to. I do know that I'm going to use the equation on the top right. v equals at, because they keep talking about acceleration in this problem. I know I already have the time. That's good. I don't know the acceleration. That's my unknown. I have a v for velocity here, and I have two velocities here. This is interesting. Maybe I could use the change in velocity is equal to the acceleration times time. So let's try that. The change in anything is the final minus the initial. So I'm going to say the velocity final minus the velocity initial. So the change in velocity, or the 46.1 minus the 18.5, is going to be equal to acceleration times time. Let's substitute. 46.1 minus 18.5 is equal to a times t, and I do know t is 2.47 seconds. So I will leave you to do the rest of the algebra. First do 46.1 minus 18.5, write the result there on the left side of the equation, equals 2.47a. And I'll let you divide both sides and solve for a. Let's take a look at the third one to get you started. It looks like we also have something with acceleration. So I would choose the equation that has acceleration in it. We know that we have a speed. We know that we have a time. They ask for the acceleration. You can take it from there. Good luck. Give all of them a try. You get a point.